Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic and third pattern, which is stack simulation and undo operation. So wherever we have to do undo operation, why stack is more optimized, we are continuously seeing in every video. And today we will do the second question, which is remove all adjacent duplicates. So let's read the problem statement. As you can see, you are given a string consisting of lowercase English letters. Okay, only lowercase as it mentioned. Okay, a duplicate removal consists of choosing two adjacent and equal letters. So basically we have to remove all such duplicates. As you can see here in the example, A, once BB found, so BB will get removed, and once BB will get removed, again AA, similar, will collide. Again AA will get removed, and at the end we will have CA, and that's what expected you have to return. But as you can see the constraint, it says 1 to 10 power 5, and you know, if you are following my playlist, then in every video we talk about ki beyond 10 power 8 operations, correct, it will give us TLE. Beyond 10 power 8 sometimes it's slower at 10 4 into 10 power 8, 5 into 10 power 8, sometimes it gets submitted as well, but again depending on the logic. But beyond it goes to 10 power 9, for sure it will give us TLE. So as the length is 10 power 5, so n square will become 10 power 10, and that will not be acceptable. So hence we need to optimize. But first we'll see the brute force code here. So as you can see, here is the string given. So what, how can we think for the brute force? Very simple. We'll start from ith index from here, and how can we say ki yes, there is a duplicate? Can I say if I am at I, if I plus 1 and I are matching, I can say it is duplicate, so we can remove, yeah, we can think of. But if we'll remove this and this, again, if we'll remove this and this, so you know, it will rearrange itself, correct? But this is not list, this is string, and string is immutable, correct? So for this you have to make another string builder, and what you will do, this I and I plus 1 is not same, correct? Like I is A and I plus 1 is B. These are not same, so hence we are not going to delete A, correct? So in our string builder, let's say S1, we will add this A. Can I say? Yes. Now we will move this I ahead at B. Now is this I and I plus 1 same? Yes. So can I say, again, can I say this B and this B should not be added? Yes. So definitely we will skip this. But can we skip two things? No. Why? Because what if there is one more B, and if you skip two, so this B won't be able to remove, but as it says ki every duplicate should have been removed, so all B should get deleted. So hence we will only do skip for one more. Again for this I, and we will say suppose there is one more B, so I plus 1 same, yes, so again we will do this one more skip, okay? But here it's not. So what we'll do, we'll again move ahead, and now this A character will get added. Why? Because this A is not matching with next character. So now we will add this A, correct? Again now we'll move this ahead at C, we'll add C, again A, add A. But is this final answer? No. Again we have to run the another for loop. Can I say? Yes. Again this A matching, so we have to remove. But why we need to do this again? See, once we removed now, it does not guarantee ki moving forward and the backward ones are not same, because as you already encountered A was not matching B, so you can say yes, no duplicacy. But the moment you removed B, now this next A is matching with the previous A. So basically you have to delete this previous A now from the string builder. Are you getting my point? Yes. So means we already encountered A previously, and now we moved ahead, again we are going back to delete. What data structure we have to use? Stack, definitely, yes. But for the brute force code, once encountered everything, again we have to run the another for loop, correct? Delete this AA, and now at the end CA will found. But how can we say ki how many times we have to run the for loop? Until or unless we are going to run the for loop again and again, we cannot say ki yes, all duplicates has been removed. So we'll add a flag type thing ki deleted, yes. So once B and B got deleted now, I'll make a flag true saying ki hey, I don't know this current one or previous one are matching or not. So try running one more time for loop. So we'll make a flag true, okay? Because the flag was true, when we'll come here, A and A gets deleted. Again this C, correct? And I don't know previous character is matching or not, correct? So again one more type flag. Here we already know ki, this C is not going to match with the previous because previous does not exist. But again, as A and A is going to be deleted, so we don't know next one and previous one is going to match or not as per the previous case A and A. So still flag is on. Next time when A get deleted, even you will start from here, you will not find any such cases where you deleted anything. So now once you found CA, when you will run the for loop again to delete something, you will not be able to delete anything. So now this time flag won't get activated. So next time once the flag is off or false, we will not run the for loop again. But the time complexity is, can I say O of n square? No, not O of n square. Why? Because see, the length was 5, but you have run the for loop only for 2 times. Can I say? Yes, only for 2 times, correct? Or at max 3 times. Length was 5 now. So basically, it's not O of n square, but it is greater than O of n. Why? Because here the number of duplicates were, one time we remove this and second time we are going to remove this, correct? So it is greater than O of n because that many number of times for loop you are going to run, correct? That many number of times. So I can say it depends on the duplicates also, but in the worst case, let's see in the worst case. Suppose we have A, B, C, D, D, C, B, A. Okay, D get deleted, flag will be on. One more type you will run the for loop. Okay, like first time you run, second time again you will run because flag is activated because you deleted something, correct? So next character and previous character might be same, and here it is. Again you will run A, B, C, C, B, A, but you will delete this C, C. Again the flag will be get activated. So again next and previous might be same. So third time also A, B, B, A, because you deleted, again the flag will get activated. My next character and previous character will be same. Yes. So you will again run this, you will again run this and delete this. So for 1, 2, 3, 4, 5, 6, 7, 8. For 8 length, how many times you have run the for loop? Nearly. In the worst case, like what if? Like they are arranged in such a way that all will be duplicate. We always talk about time complexity as per the worst case, right? So it will be O of n for the for loop and O of n by 2 times means O of n square only, correct? This is not optimized. How can we, optimize? Definitely, because we are going back again and again. So we'll check the, stack. So once A found, we'll add this in stack. Okay. Now B found, add it in stack. Okay. Now next time B, we'll check in the stack top. Is it same? Yes. So we'll remove from the stack. Correct. Now we'll move this ahead. A. Again checked from stack. Is it same? Yes. So we'll remove this from stack. Again moved C. Added A. Added. Out of index. Done. What are the number of characters in the stack? A and C. Time complexity we have used. We have iterated to all the index at once. That's it. Correct. So time complexity will be O of n. Yes. What about the space complexity? Obviously we are going to take O of n in worst case. What if there is no duplicates, like, or duplicates also but not in consecutive, like A, B, C, D, again A, B, C, D, again A, B, C, D, and so on. Then no such characters are there in adjacent manner that they are duplicates. No, they are not. So hence in this case you will end up adding everything in the stack. So O of n space complexity. And time complexity is O of n, which is far better optimized approach compared to the brute force one. So first let's see the brute force code and then we will optimize it also. So here is the code. First we will need the flag, correct? Like how many number of times we have to run the for loop again and again. Okay, so while this flag is true, so initially it will be true because first time so we want to run the for loop, right? So next time for this iteration we will change the flag to false. Okay, if no such removal you will find in the code now. So from next time don't run the for loop. Okay. Now we'll make a string builder. Why? Because whatever string we are going to make, that we have to save because string is immutable, right? So we'll run the for loop from 0 to last index and until this I index is hitting the last index, and also every ith character and I plus 1th character are same. Can I say I have to skip, means I don't want to take that? Yes. So I plus plus. Okay. Like I will not add that character in my string builder. And again switch on the flag. Means for next time also I want to check again, because this time I deleted something. What if the next character and the previous character got matched? So for that, one more time I want to run it. Okay. Or else, if no such match, then in the string builder, simply we have to add that character. Okay. And we have to change it into, string also, because, if you don't know, like string builder is a, array. It's not string. Okay. Now, again the flag is on, again we will do the same operation until the flag is off, So in this case, BB will get deleted. Again, as it's been deleted, so we will again run next time. What if the next and previous will match? Here it's matching. Again we will delete. Again, what if the next and previous will match? Again we'll run 3 times, but we will find this C and A. So at the end we have to change it, correct? So at the end, whatever is S, which is string, we will return once the flag will become off and we have run everything. So it won't be O of n square for sure, but in the worst case it will be, as I already shown you the example, what can be the worst case. What if it arranged in such a manner that after every popping it will delete another ones. Okay. So TLE, why? Because I showed you in the worst case, if it's arranged in such a manner, so it will take O of n square. And as in this constraint, n was 10 power 5, as you can see. So n square will become 10 power 10. Definitely it's not acceptable. So we saw this, TLE. So how can we optimize? Definitely with stack. But before writing the stack code, I want to discuss something. If like we will add everything in the stack, and at the end we have to convert this into a string, CA, and then we have to return, correct? Why, we can do one more thing now. Why? Because in the stack we inserted A, B, and from the current perspective we are just taking the previous character and we deleted and we deleted. We can do the similar thing without using stack also by using string builder. See, the idea will be stack only, but we are not using it. See, we have used string builder. Okay, let's call it SB. Okay, so in SB, A will get added, correct? B will get added next time. Yes. Now the second B we encountered, we'll check the last B. Is it matching? Yes. So we will delete this. O of 1 time complexity we took to delete, correct? Yes. Now we'll move to next A. Again, is this previous from string builder, is it matching? We'll delete. Okay. Now again we move to C. C get added, because earlier we don't have anything in a string builder to check. Now we'll move to A. Is it matching? No. So A will get added. And now we'll come outside the index. So at the end string builder is CA, so we'll convert this into string and we'll return this. But the time complexity is same, space is almost same. So which code will be faster? See, string builder will be faster compared to stack. Why? Because the inner implementation of stack and string, if you don't know, internally stack is synchronized. For every push and pop operation, it uses lock on it, which takes more time complexity because of the safety checks. But in string builder, it's simple array. Okay, so for any push or pop, we are not using any locks over it. So hence, comparatively to stack, string builder is faster. So the idea behind the string builder we are using here is stack only. But instead of using stack data structure, we are using string builder here. And if you'll talk about this difference in the interview, trust me, you are going to make it. So can we write the code for this? So first we will make a string builder. String builder SB is equal to new string builder. Okay. Now we want to run a for loop for each loop character on s.toChar array. Okay. One by one we'll read every character. Now we have to check for the length of the string builder also, because when we want to check the previous character at string builder, the length should be positive, like it should not be empty. We cannot check the previous character, correct? So we'll calculate the length also, sb.length, correct? Once we calculated now we have to check if length is greater than 0. Now we have something in the string builder, and sb dot, we want to read the last character element. So sb.char at last character means length minus 1. If it is equal to the current character ch, then we can say we have to delete. So sb dot delete char at, okay, which one? Last one. Yes. Else suppose it does not match, or there is no such character to match, so definitely in the SB we will append the last the ch. Okay, so we will append that. After coming outside the for loop, whatever is there in the string builder, that we have to return, but as it is array, so we have to convert it into string. So we'll do return sb dot to string, okay, and this we will return. So let's run this. As you can see, it's passing. So now we can try to submit this code as well, and it's obviously faster. Why? Because we have used StringBuilder here, and also the time complexity is O of n, correct, and space complexity will also be O of n. Why? Because we are using the string outside, correct. We are not manipulating the same s, we are making another string. Yes, so it will be faster, but it is very easy. So this was a Java code. Now here is a Python code. We make a stack here. Why? Because in Java we have StringBuilder, but in Python we don't have such, correct. And here is a C++ code. Here also we make string instead of stack, and definitely it will be faster, correct. So I hope you understood the brute force code and the optimized code, and also the reason behind why StringBuilder is faster compared to the stack, because of the internal implementation. Okay, so if you understood, then definitely you can come up with me and you can mark the second question as done. Okay, so I hope and I expect you all have understood. If yes, then definitely I will expect a like and a comment on this video, and subscribe the channel if not yet subscribed, guys, because you know it gives more motivation to make more such videos, that too pattern wise. And if you feel this channel can be helpful for your friends as well, then what are you waiting for? Just go and share the channel to them and let's learn together. And if in case you are new and if you don't have the sheet link, I'll add the sheet link there in the description. And if you want to connect with me on any social media, I'm very active on Instagram, LinkedIn and Twitter. Please do reach out to me in case of any guidance. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.